So today we are going to discuss the area of a surface of revolution. So let's start first from the definition of surface of revolution. So it says that if the graph of a continuous function is revolved about a line, the resulting surface is a surface of revolution. So the area of a surface of revolution is derived from the formula for the lateral surface area of the prostome of a right circular cone. Consider the line segment in figure 7.43 where L is the length of the line segment, R sub 1 is the radius at the left end of the line segment, and R sub 2 is the radius at the right end of the line segment. When the line segment is revolved about its axis of revolution, it forms a prostome of a right circular cone with S is equal to 2 pi RL. So this is the formula for the lateral surface area of prostome, where R is 1/2 of the sum of R1 and R2, or this is known as the average radius of prostome. So let y is equal to f of x have a continuous derivative on the interval AB. The area S of the surface of revolution formed by revolving the graph of f about a horizontal or vertical axis is S is equal to 2 pi times the integral of r of x times the square root of 1 plus the square of the derivative of f of x dx from a to b. So this formula is y is a function of x, where r of x is the distance between the graph of f and the axis of revolution. If x equals g of y on the interval c d, then the surface area is s is equal to 2 pi times the integral of r of y times the square root of 1 plus the square of the derivative of g of y dy from c to d. So this equation is x is a function of y, where r of y is the distance between the graph of g and the axis of revolution. So let's try to utilize the formulas given on this definition of the area of a surface of revolution. So number one, find the area of the surface formed by revolving the graph of f of x equals x cubed on the interval 0, 1 about the x-axis as shown in the figure. So to solve for this, so we know that the distance between the x-axis and the graph of f is r of x equals f of x. So r of x equals f of x. And to take the derivative of this, so we have now f of x is equal to x cubed. So taking the derivative of the function, so we have 3x squared. So writing now the formula for the surface area, so we have S is equal to 2 pi times the integral of r of x times the square root of 1 plus f prime of x. So the quantity of this will be squared of dx from the interval of a to b. So by substitution, we know that a equals 0, b equals 1, and rx now is equal to the f of x. So therefore, we have 2 pi times the integral of the meaning of rx is equal to fx, which is now x cubed, times the integral of 1 plus the derivative is 3x squared, and then we're going to square according to the formula of dx with the interval from 0 to 1. Simplifying now our radicand, we have 2 pi times the integral of x cubed times This is now 1 plus the square of 3x squared is 9x to the power of 4 of dx. Okay, so from here, I will let u equals 1 plus 9x to the power of 4. Then du now will give us 36x cubed of dx. So on the integrand, we have x cubed dx. So I will define now x cubed dx, which is now equal to du over 36. Rewriting now the given in terms of u and du, so we have now s is equal to 2 pi times the integral of, we have the square root of 1 plus 9x raised to 4 can be written now as u raised to 1 half. And x cubed dx is defined as du over 36. So I will just write here du over 36 with the interval from 0 to 1, which I also forgot it here, from 0 to 1. So integrating this one now will give us 2 pi times 1 over 36. So we have times u raised to 3 halves all over 3 halves, or I can write now here as 1 over 36 times 2 thirds, evaluated from 0 to 1. So simplifying this further, so I can write now 4 pi over 108 is the product of 36 times 3. And then we have u to the power of 3 halves to be evaluated at 0, 1. So reducing this fraction of 4 over 108, that will give us now pi over 27 times, let us write now the meaning of u, which is now 1 plus 9x to the power of 4. And this will be raised to the power of 3 halves. And then to be evaluated from 0 to 1. So by using the fundamental theorem of calculus, so it will give us now the answer of pi over 27 times 10 to the power of 3 halves minus 1. And this is now the final answer. For number 2, find the area of the surface by revolving the graph of f of x equals x squared on the interval of 0 to the square root of 2 about the y-axis. So in this case, the distance between the graph of f and y-axis is r of x is equal to x. That is actually coming from y is equal to x squared. We know that y is equivalent to f of x, and solving now for x, we have now square root of y is equal to x. And this is what I'm trying to say, that this value of x equals the square root of y is equivalent to our r of x. Now we know that from the original given, f of x is equal to x squared. So taking the derivative of this, we have now equals 2x. So f prime of x equals 2x. So we can now determine the surface area. So writing the formula for the surface area, so we have s is equal to 2 pi times the integral of r of x times the square root of 1 plus the derivative of f of x, and then this will be squared of dx from a to b. So by substitution, I have 2 pi times the integral of the meaning of rx is equal to x. So therefore, x times the square root of 1 plus the derivative of x, or f prime of x, equals 2x and then squared of dx. By simplification, so we can write now 2 pi. I forgot to write here. So that with the interval from 0 to square root of 2. Okay, so 2 pi times the integral of x times the square root of 1 plus the square of 2x is 4x squared of dx from 0 to square root of 2. Now, solving now for this integrand, I let u is equal to, okay, so I let u is equal to 1 plus 4x squared, and du now is equal to 8x dx. Since x dx is visible on the integrand, so therefore we have a coefficient factor of 1/8. Rewriting this one, we have 2 pi times the coefficient factor is 1 over 8 times the integral of, we have u raised to 1 half, and the meaning of x dx now will just give us the du, because I already write the 1/8 as the constant multiplier. So now simplifying this, so we have now 2 pi times 1/8, it will give us now pi over 4 times u to the power of 3 halves over 3 halves, or I can write now as 2/3 of u raised to 3 halves, and this will be evaluated from 0 to square root of 2. So simplifying this further by using the fundamental theorem of calculus, so it will just give us the surface area of 13 pi over 3. For number 3, find the surface area of a sphere with radius r equals 3 centimeter. Okay, to solve for this, we're going to use now the equation of a circle, which is now x squared plus y squared is equal to r squared. Since r is given, which is the radius, so therefore this becomes now x squared plus y squared is equal to 9. And solving for y, we have now y squared is equal to 9 minus x squared. So to remove the power of 2, therefore we take the square root of both sides. So therefore y equals the square root of 9 minus x squared. This has a sign of plus and minus. So from here, so to solve for the intervals in terms of x, so let y be 0. So 0 is equal to the square root of 9 minus x squared. And then, so to solve for x squared, we are going to square both sides. So therefore, 0 is equal to 9 minus x squared. And then, transpose x squared to solve for x. So we have x squared is equal to 9, and x now is equal to plus and minus 3. So the interval now, as you can see, in terms of x, so we have here now from negative 3 to positive 3. Okay. Now let us use the arc between x equals 0 and x equals 3 and rotate it. So this will give us half of the surface area of the sphere. So we need to multiply the result by 2 to obtain the whole surface area. Since I'm only taking first from 0 to 3. So if you're going to take the whole, then the whole surface area, that is why we need to multiply it by 2. So before we're going to solve for the surface area, so what we need more is the derivative of y. So solving for the derivative now, we have y prime is equal to 1 half times 9 minus x squared to the power of negative 1 half times the derivative of 9 minus x squared is equal to negative 2x. So simplifying this further, so 2 here in the denominator and 2 there in the numerator will be cancelled. So we can write now the negative x over the square root of 9 minus x squared. So the square root of 9 minus x squared is coming from the quantity of 9 minus x squared to the power of negative 1 half. So this is now our derivative. So after that, since we do have now the derivative, so let us solve now for the surface area. So the surface area is equal to 2 times 2 pi times the integral of the value of Rx now is the square root of 9 minus x squared times the square root of 1 plus we have negative x over the square root of 9 minus x squared, which is this is actually the derivative, and then we're going to square of dx with the interval from 0 to 3. So simplifying this further, we can have now s is equal to 4 pi times the integral of the square root of 9 minus x squared times the square root of 1 plus the square of this will give us x squared 9 minus x squared. Okay, from 0 to 3. Now we have 4 pi, the integral of the square root of 9 minus x squared times, simplifying this further, so I can have a common denominator of 9 minus x squared. Then 9 minus x squared times 1 is 9 minus x squared, so plus x squared. So we have now equals to 9 of dx. Now simplify it further. So we have now 4 pi times the integral of the square root of 9 minus x squared times, I'm going to separate the numerator and denominator. So therefore, the square root of 9 is equal to 3. And the denominator now will give us the square root of 9 minus x squared of dx. So we can see clearly that this one and this one will be cancelled. So therefore, we have now s is equal to 4 pi times the integral of 3 dx. So the integration of 3 dx is just 3x. We have 4 pi times 3x, and this will be evaluated from 0 to 3. So I forgot here 0 to 3. Evaluating this integral now, so we have the final answer of 36 pi centimeter squared. Number 4, find the area of the surface generated by revolving the curve y equals 2 square root of x, and x is greater than or equal to 1, and x is greater than or equal to 2 about the x-axis. So to solve for this, so first we're going to find the derivative of y. So we have here y is equal to 2 square root of x. So the derivative of that, we have dy over dx is equal to 2 times 1/2 of x to the power of negative 1/2. Or this is just equal to 1 over the square root of x. That is for dy over dx. So after knowing the value of the derivative, so we can write now the formula in finding the area of the surface. So we have s now is equal to 2 pi times the integral of 2 square root of x times the integral of 1 plus the square of 1 over the square root of x of dx from 1 to 2. So simplifying that further, we have 2 pi times the integral of 2 square root of x times we have 1 plus the square of 1 is 1. The square of the square root of x is just x of dx. So simplifying this again in that part, so we have now 2 pi times the integral of 2 square root of x. So we have times the square root of, so the LCD there is x. So this is now x plus 1 of dx. So we have here 2 pi times the square root of 2 square root of x times the square root of x plus 1 all over x of dx. So simplify this again. So we have now 2 pi times the integral of 2 square root of x times the square root of x plus 1 over the square root of x. So I separated that numerator and denominator so that we can see clearly that the square root of x and the square root of x here can be cancelled. So this is from 1 to 2. So this is now cancelled. So the remaining integrand now we have 2 pi times the integral of 2 times the square root of x plus 1 of dx from 1 to 2. Now to integrate that one, we can let u, so I will just write here. So let u is equal to x plus 1. So du now is just equal to dx. So therefore, I can write now as 2 pi times 2 times the integral of u raised to 1 half of du. So integrating that one, so we have now 4 pi times u to the power of 3 halves over 3 halves, or I can write 4 pi times 2 thirds that can be evaluated from 1 to 2. So rewriting that one here again, so we have 4 pi times 2 thirds, it will give us now 8 pi over 3 times the meaning of u, which is now x plus 1 to the power of 3 halves that is evaluated from 1 to 2. So, by using the fundamental theorem of calculus to evaluate the integrals, so it will give us now the answer of 8 pi over 3 times 3 square root of 3 minus 2 square root of 2. So, revolution about the y-axis. So, for revolution about the y-axis, we interchange x and y in equation number 3. So, surface area for revolution about the y-axis. If x equals g of y and g of y is greater than or equal to 0, is continuously differentiable on the interval c, d. So the area of the surface generated by revolving the graph of x equals g of y about the y-axis is s is equal to the integral of 2 pi x times the square root of 1 plus the square of dx over dy of dy from c to d. Or we can write that one as the integral of 2 pi of g of y times the square root of 1 plus the square of the derivative of g of y dy evaluated from c to d. Now let us try to utilize this formula in the next problem. So the number 5, the line segment x equals 1 minus y, and y is greater than or equal to 0 and y is less than or equal to 1 is revolved about the y-axis to generate the cone in the figure below. So find its lateral surface area, which excludes the base area. That is what we mean by lateral surface area. Okay, so let us recall the formula for lateral surface area. I will just use the acronym or the initial of the lateral surface area. So I will write here LSA, which stands for lateral surface area, which is equal to the base of the circumference over 2 times the slant height. So that is now equivalent to pi square root of 2. So the formula now for the lateral surface area is equal to base circumference over 2 times the slant height, or that gives us pi square root of 2. So let us take first the derivative of the function, which is now x is equal to 1 minus y. So the derivative of that will become dx over dy is equal to negative 1. So writing the formula now, we have s is equal to the integral of 2 pi x times the square root of 1 plus the square of the derivative, which is now dx over dy, so the square of dy from C to D. We know that C is 0 and D is equal to 1. And x here is also equal to 1 minus y. So by substitution, so we can write now the integral of 2 pi times 1 minus y times the integral of 1 plus, we have the derivative is negative 1 and then squared of dy from 0 to 1. So simplifying that one, we have the integral of, we have 2 pi times 1 minus y times the square root of 2. 2 because the square of negative 1 is 1, so plus 1, so it gives us now the square root of 2 of dy. Then, rewriting the given, I will write the constant outside the integral sign. So we have now s is equal to, so the constant term here now is, we have 2 square root of 2 pi times the integral of 1 minus y dy. So it is now easier to integrate the term or the integrand. So we have 2 square root of 2 pi. The integration of that will become y minus y squared over 2. This will be evaluated from 0 to 1. So by using the fundamental theorem of calculus to evaluate these integrands, so it will give us now the answer of pi over 2, which is now equal to the formula for the lateral surface area.